The cooling system, again, as Mike said, we were at the point we had cooling trailers outside, especially in the summertime months. And like everybody else that's built a data center over a long period of time, we had a pretty broad variety of standard computer room air conditioning units, crack units, raised floor, air chillers, and just really very limited flexibility in projecting the cooling to where we needed it. And so the effect of that was, we had to cool everything. We cooled the entire data center, and we got it down to whatever temperature we needed. We just indiscriminately did that really everywhere in the data centers and the labs. And that's relatively unpleasant for somebody that is developing gear because they have to be in there testing it. So, it's not a lights out facility. We actually have engineering guys that are in there testing and rewiring and plugging and swapping boards and things like that. So it's a relatively unpleasant environment for those guys. But it also is just inefficient because we're cooling a bunch of space that we don't need to really be cooling. The cooling system that we put in this campus started with the design of really a custom in-row cooling system. It was built with Brocade and help from a couple of our engineering partners here in the San Jose area. And those in-row cooling units were about 70% more efficient than a standard crack unit or a raised floor air conditioner, and about 40% more efficient than any of the other in-row cooling units that we can find in the industry. Very high efficiency motors in them, variable frequency drives, high efficiency fans, internal temperature monitoring, and again, a building management system that's able to individually take the fans and turn those up and turn those down as load changes and balance changes. And we also implemented a hot row containment system. So this is a graphic of the thermal analysis that's in the data center. You can see the in-row cooling units that are put there. They're exactly the same size as a rack unit of equipment. So if we physically want to put denser equipment into the data center, we simply take a rack of equipment out, put an in-row cooling in, plumb it up to the chilled water system, and we can have additional cooling put in the right spot in the data center where we need it, and we can do it in the span of 2 or 3 days instead of doing it over the course of 3 or 4 months. It also gives us the ability to really only cool half the data center. So we cool one aisle, let that air be dragged through the equipment. All the data center equipment today is front to back airflow. It gets exhausted in the hot row aisle. We contain that hot air, and we can run those at independent temperatures. So the hot rows can be run, I think, as high as 110 degrees if we chose to run them that high. So we really are only cooling about half the floor space. And those two things together result in about 75% less energy usage in the cooling system over what we did in our previous data centers. We also use flat floors in all of our data centers. We have no raised floors in any of the data centers. And that has two benefits. One is it makes more efficient of the usage of the square footage in the data centers because I don't have to build ramps. I don't have to put cutouts for doors. I don't have to put stairs in. I get to use all that space for rack units. And the other benefit is I get to use taller rack units because I don't have to accommodate a raised floor. And when you go to hotter environments, as I'm sure Casey will tell you, you need more and more raised floor to get the airflow that you need. So these flat floor designs are very, very efficient by being able to pack in more rack units and be able to use taller rack units that are in here. About 12% more. So the result of this was 13 million kilowatt hours annually of saved energy usage that was here. We've also supplemented this with a 550 kilowatt solar array that sits on the top of the garage that saves us about 750,000 kilowatt hours a year. That's a SunPower system that's out there. I think some of you are going to go actually tour that up in the garage. But as you walk through the campus, you can see the top of it actually hanging over the top of the garage. I like to tell people that we may be one of the only firms in the Valley that can actually run our IT facility, although they're not directly connected. But we have enough capacity in our solar array to actually run our entire IT facility. So the two of those offset each other as long as the sun's shining. We still rely on PG&E for the rest of it. We had about 4,500 tons of CO2 reductions coming over here and about 40% less water usage in this campus. And that comes from the high efficiency chillers. It also comes from the use of plants and artificial turf and water recovery systems and things like that you'll see throughout the campus. The net on this is, it's $1.5 million in yearly operational savings. And we have to also thank PG&E both for being a sponsor of this event, but for also providing us rebates that total a little over $2 million for the efficiencies that we've built in the campus, which I think to date is the largest rebate that has ever been provided under the PG&E programs. So that's great to get back. So just to close out and summarize here, I hope one of the things that I've tried to get across this morning is that data centers, although they're a pretty dynamic beast, they are today in a very, very rapid state of transition, and that trend is actually accelerating. As we get more devices on the network, more virtualization, more traffic, more storage, those things are getting bigger, but they're also getting more distributed. And the loads within the data center are much, much more dynamic. The data centers where we put everything in and didn't change anything, that's a thing of the past. The data centers today are much more fluid, they're much more dynamic, and they're becoming much dense. They may be becoming physically smaller in the case of a lot of enterprises, but they're becoming much denser. And many of the requirements that we're seeing in data centers today are going to start showing up in wiring closets, in these server closets that Casey talked about, in much smaller facilities around the world as those facilities continue to be distributed. And the good news for us and the great thing about summits and exchanges like this is that the technologies are out there to get to very, very high levels of efficiency and to save a ton of energy while we accommodate the traffic growth and the compute growth and the changes that we see going on in the data center. So it's great to have summits like this and to have all of you here with me. So with that, I'll conclude my remarks, and thank you for your time, and welcome you again to Brocade. It's going to be a great day. And so let me turn it back over to Bob Hines.